Hello guys, welcome to Academy if you're new, and welcome back if you're part of the family already. First of all, I want to appreciate everyone for subscribing. For those that have subscribed, thank you very much. Thank you for showing that what I'm really doing is, it's getting to you and you find it appreciative. And for those that are, you know, that are not subscribed, that have not subscribed, please help me to subscribe. It's very important. Okay, it's like a metric for me to know that what I'm doing is really making sense. So please subscribe, and I promise that it's gonna be a promising one. Okay, so we are starting chapter 3 in this video. So this chapter 3 is computer software. It is IT, as you can see from your screen. We are dealing with IT, information technology, which is for ATS2 students. Computer software is what we are talking about in chapter 3, computer software. All right, and chapter 1 holistically looked at how computer works. Then chapter 2 we discussed the hardware components of the computer, where we discuss the inputs, outputs, the CPU, that's the main memory, and the processor, which we said is ALU and CU, that's control units, arithmetic logic units. And we also look at the secondary storage and their types. You can go to the playlist and watch the parts, okay, the videos. They are there on the IT playlist to watch. So this is going to be the first part. Just like I said, chapter 3 is going to be in two parts. This is just the part 1. Okay. This part 1 has 14 slides. I know it is lengthier than what I used to do because of the fact that the subsections kind of fuse together, and I think it is more important to do it this way. Okay, it is more beneficial to have it in two parts, the first 14 and the second part, which is going to consist of about, I think, 12 slides. Okay, so let's quickly dive right into it. So in this chapter we explore the word computer software. Okay, we explore the word computer, or the word of computer software. So what you're going to discover is what software is. You're going to discover what software is, the different types of softwares, their functions, and the systems that help a computer work smartly. Okay, so that is what we are going to discuss in this chapter. So what you are going to learn, um, explain what computer software is, and please have it in mind that this is what you should be able to do after watching the two parts. Okay, after watching chapter 3 video, you should be able to explain computer software, differentiate between system software and application software, identify the major types of system software. Okay, there are 7 or 8 types of system software. You should be able to identify the major types of system software, understand the role of the operating systems, which is the important one, the role of the operating system, recognize utility programs, loaders, and editors, understand language processors and their types, know examples of operating systems, understand how software helps us to get work done as a computer. Okay, so those are the 8 key learning outcomes. Okay, what you must learn, what you should be able to do after watching chapter 3 video. So what is software? Because that is the next question. What is software? So software is a set of instructions. That's what you should put in mind. When defining, this is what I like to do as a person. I like to have keywords, because I know I can say so many things, but so far the keywords are there, I will have my full mark. Okay, I can say software can be defined as the definition. The definition of software is I must include the keywords. So what are the keywords in defining software? Number one is set of instructions. Okay, software is a set of instructions or programs. All right, that's number one. Number two is that tells a computer, tells the computer, not human beings. It tells the computer what to do and how to do it. As simple as that. Okay? Software is a set of instructions or programs that tell a computer what to do and how to do it. Okay? And when we're talking about a computer, we are referring to uh, hardware components, the input device, the output device, the hardware component, the CPU, the storage, and all of it, the hardware components, okay, that we discussed in chapter 2. The software tells the hardware component what to do and how to do it, okay, tells the hardware component what to do and how to do it. So hardware is the body of the computer, so software is the brain that makes the body what works. Now let's look at the categories of software. Now we have two categories of software. We have the system software and we have the application software. Okay, and that's why I said part 1 is lengthy, because it discusses both system software and application software. Okay, that's why I made it like that. So system software manages and controls the computer's hardware and provides a platform for other programs to run. When we say other programs, we are referring to what? We are referring to application software. Okay, so system software manages and controls the computer's hardware and provides a platform for other programs to what? To run. Examples of system software: we have Windows, we have Linux, we have Android, we have device drivers, we have Apple OS, the iOS, and we have we have a lot of them. Okay, we have a lot of them. We have a lot of system software. Okay, but these are the common ones. Now, what are application software? So application software help users. Application software helps users perform specific tasks. It helps users to perform specific tasks. For those that are asking, what do I use to record my lectures? I use Zona Plus Plus. This the screen that you are seeing. I use Zona Plus Plus. Then I use OBS. Okay, it's an open source video recorder. So OBS is an example of application software because it helps me perform a specific task. I cannot go to OBS and say I want to edit pictures, because that's not the function of OBS Studio. You know VLC players, you know your WhatsApp, you know your TikTok. The work of TikTok, the task of TikTok is kind of different from um, WhatsApp. It's different from WPS. So all of those things are application software. Okay, but system software is Android that makes everything to work. Okay, and we are still going to explain extensively on each one of them. Okay, so think about it. A car without fuel cannot move. So a computer without software cannot do what? Cannot do anything. A computer without software cannot do anything. So easy memory trick: software is equals to soft instructions. Hardware is equals to hard physical what? Parts. So questions that can come out from this slide is: what is software? Define software. State two categories of software. Give examples of system software. Explain the relationship between software and hardware. And I believe you should be able to do that from the slide. So let's move on to the next one. Okay, I think we have key summary. So what is the summary here? Number one, software is a set of instructions that makes a computer work. That's number one. Number two, there are two main categories of software, which is system software and application software. The third one is system software manages the computer. Application software helps users do tasks. And operating system is the most important system software. Okay, so those are the key summary for slide one. Now let's move on to the next slide. We want to look at system software. Okay, I told you we have software. So software is divided into two. which is the system software and application software. Now we want to look at system software. So what is system software? System software is a collection, okay, of programs designed to manage the computer's hardware. In any way you want to define system software, please include manage the computer's hardware and provide a suitable environment for applications programs to run. Okay, very important. Manage the computer's hardware and provide a suitable environment for application software to run, application programs, application software to run. So it handles tasks like controlling memory, managing files, processing data, and operating devices. Okay, every computer comes with system software because it is essential for the computer to work. System software is important for the computer to work. You know, you hear something like Android 2.0 and Android 1.7. This is Android 11, Android 12, iOS 17, iOS 16. Those are system software. Okay, no, those are operating system. Okay, and is an example of system software. Is part of system software. All right, those are operating system, but are part of system software because system software is a collection of programs. Okay, is a collection of programs designed to manage the computer hardware as a whole, to manage the computer hardware as a whole, and to provide a suitable environment for application programs to run. So, in simple words, system software is the backbone of the computer. It runs in the background and makes sure the hardware works properly and that other programs can run smoothly. Now let's move on to types of system software. We have number one, operating system. The examples I was given earlier, that is Android, iOS, Windows, Linux, and other examples. Okay, so we have language processor, and I'm coming. All of these are the things we will look at one after the other. Then we have utility programs, we have loaders, and we have editors. I know it's kind of very confusing to you because as an accounting student, what do you need all of these things for? But I've told you in the last video that it is important that you know all of this because you will be using softwares, you'll be using the computer. Okay, there's no how that you want to be a financial analyst CFA without using a computer, or working in a bank without using a computer, or or being an analyst without using a computer, either data or finance without using a computer, or even as an employee, a junior accountant without using what? A computer, because that is the order of the day. So you need to know everything that has to do with a computer, okay, so that you can be fit for what? For the job role. Okay, so we are starting with operating system. Operating system manages all computer resources and acts as an interface between the user and hardware. Operating system manages all the computer resources and acts as an interface between the user and hardware, e.g., you have Windows, Linux, Android, just like I said earlier. Now we have language processor. Language processor translates user written programs, which we call the source code, into machine language so the computer can understand. And we have a assembler, compiler, interpreter as an example. See, just listen, okay? We are still coming to explain it, in which I will use relatable scenarios, something that you can really relate to explain all of this, in which you understand. Okay, so number three is utility programs. And utility programs performs maintenance, and support tasks to keep the system running efficiently. Example, antivirus, disk cleanup, backup, and the likes. Now we have loaders. Loader loads programs from secondary storage into main memory so that they can be executed. Editors used to create, edit, format, and modify programs source code. Okay, example, text editor, linkage editor, and the likes. So system software works in the background. You may not see it, but without it, your computer and apps will not run. Very, very important. So why is system software important? System software important because it controls and coordinates all hardware devices. It provides a platform for application software. It improves efficiency and security. It makes the computer easy to use. Examples, Windows, Linux, Android, Mac OS, Chrome OS. All these are system what? Software. Now, questions that can come from this: define system software, list the types of system software, state the functions of any one type, give examples of system software, and you should be able to answer this from this slide. Okay, now we are moving to the next one. Okay, so what are the key takeaways? Like the summary: system software is the foundation of every computer. It manages hardware and creates an environment for other programs. The five main types are operating system, language processor, utility programs, loader, and editors. Without system software, your computer cannot start, runs programs, or perform any useful task. So those are the important key takeaways. Now let's move on to the third slide. We have operating system. We want to look at each system software. We said we have software is divided into two, which is application software and system software. We've explained what system software is, and we said we have about five types of categories of system software, in which operating system is one of those um, classification of system software. So, and that is what we want to discuss. We want to discuss each of those classifications one afterwards, one after the other. So, we are starting with operating system. So, what is operating system? Operating system is the most important system software. Just like I said earlier, is the most important. It acts as a manager. See what it does? It acts as a manager between the user and the computer hardware. So I told you, I said I'm going to give you relatable scenarios to understand all of this. Now, the most common to every student is you have a smartphone or a laptop, okay, and both are computers. All right. So I'm going to be using smartphone and laptop to explain, or your tab or anything, this device that you use to you're even using to watch this video. Okay. So I will use your phone because it's the most common. Now, there is no how you will see what you are typing without operating system. There is no how you will even see the applications that are on the phone without what? Operating system. There's no how you will play music without operating system. So operating system acts as a manager between you and your phone. Okay? Between you and your phone. It acts as a manager between you and your phone and the phone. Okay? So when you want to play music and you are scrolling to music app, you are searching the music you want to play, you press the play button and you begin to hear sound either to your earphone, your AirPod, or via the speaker or Bluetooth. All of those are being done by the operating system. Remember, operating system is under system is under what? System software. Okay? It's still under system software. But operating system is the most important system software because that is the one that interacts with the user the more. All right. So what does an operating system does? Okay. Operating system manages the computer resources and provides services that allow other programs to run. It helps the computer to what? Start up and shut down, run programs, manage files and folder, control memories and storage, handles input and output devices, your Bluetooth, your headphone, your headset. Operating system handles input and output device, protects the system from errors and unauthorized users. Now, main function of an operating system. Main function of an operating system: resource sharing. Allow different programs and users to share the computer's resources. Virtual machine: use part of the storage, that's RAM or disk, to act like extra memory when needed. We are still coming to explain that. We have input and output handling, controls how data goes in and out of the computer. Memory management keeps track of memory and ensures each program gets what it needs. We have file management, organize, store, retrieve, and protect files. Protection and error handling prevents error and protect the system and data. We have program control, decides which programs run and in what order. We have system initialization, start the computer and load the OS into memory. Okay, load the OS into memory. Now, main component of an operating system. The core part of the operating system, it controls all activities in the system and manage resources. That's supervisor role. Command language translator takes user commands in a language like basic C, Python, and translate them into machine code. We are still coming to explain that under language translator. We have the input output control system, that is, it manages all input and output devices and it ensures that data moves correctly between devices and the computer. Librarian, which means manage system libraries, collection of frequently used programs and data that can be called upon whenever it is needed. Now, without an operating system, you cannot run any application program. It is the platform that makes everything possible. That's why we said your system software also, you know, gives application program a soft landing. It makes them give them the environment to what to function. Without operating system, your WhatsApp cannot work. Without your Android, your camera cannot work. Without your Android, you cannot even check Facebook. Okay, so those cannot work. Now, examples of operating systems: we have Windows, we have Linux, we have Mac OS, Android, iOS, Chrome OS, and so many more. Now, what are the key takeaways? The operating system is the most important system software and it manages hardware resources and provide services for application programs. Okay, it performs several key functions and has four main components. That's four main components in which we have what discussed. Now, we want to move to the next slide, which is classification of operating systems. Classification of operating systems. I want you to listen at this point because we are getting serious now. So, operating systems can be classified based on how they are used and the type of environment they are designed for. They are classified based on how they are used, how they are used, and the type of environment they are designed for. So, we have 8 classifications of operating systems. We have the single user OS, multi-user OS, multi-processing OS, multitasking OS, networking OS, Windows-based OS, mobile OS, cloud OS. OS stands for operating system, so remember that. These things are not very hard to understand, but you just need to listen. So we have the single user OS. What does it mean? It means it's an operating system that is designed for one user at a time. Only one person can access the system's resources. Windows, Mac OS, Linux, Android. Okay, your phone. You are the only one that can use your phone. Or even if you are not the only one that can use your phone, at a time, only one person can use that phone. So even if I want to see something, it's either um that's your Android operating system now that is on your phone. If I want to do something with it, I have to collect your phone to be able to do it. Okay, I have to collect your phone to be able to do it. If you are saying, but we have screen sharing this thing, but you cannot scroll on that screen sharing this thing. So what I'm trying to say is, although it's still output device. It's an output device to the operating system. Okay, it's an output device to the operating system. Now, what are the key characteristics of single user OS? Limited user account. Okay, runs one task at a time mostly. User-friendly interface, personalized experience. Those are single user operating system. I'm not saying your phone is only single user operating system. It only has the characteristics of what? Single user operating system. Multi-user operating system. Multi-user operating system allows multiple users on different computers or terminals to access the system at the same time. Unix, Windows Server, Linux. Most of the servers are examples of multi-user OS. I'm going to give an example. Now, your school portal now, okay? So many students can access the server on their phone via internet, right? But that server in itself is a multi-user operating system. So that your Free Fire game, your COD, that's Call of Duty, you know, is an example of multi-user operating system. Not the one on your phone. The one on your phone is an application software, okay? But being able to communicate with different people playing the same game, at different location, can be in Nigeria and you are playing, your team member is in India, you guys are playing the game together. The server in which it, the um the connectivity is being stored is an example of multi-user operating system. Another good example is the softwares that are used, the operating systems that are used in banks. Okay, still an example of networking OS, but so many people are connected to a central server. Okay, central server. So it's an example of multi-user. The difference between multi-user and networking is that networking is referring to the server itself, while multi-user is referring to how many people are using the server at a time. Do you get it now? How many people are using the server at a time? Something could be networking and still be just single user. Okay, and another server is still networking but multiple user. So multiple user is referring to how many users at a particular time, okay, at the same time. So that is multi user. Now um multi-processing is referring to an operating system that use two or more CPUs to perform multiple tasks at the same time. Okay, that uses two or more CPUs to perform multiple tasks at the same time. In the last part of chapter 2, I was talking about my system having Core i5, which I think I used to explain a particular concept in that video. If you have not watched or you've forgotten what I talked about in that particular time, you can watch part 3 of chapter 2. You will get to that point and you understand what I'm talking about right now. So, CPU 1, CPU 2 is doing different things. Okay, so multiprocessing OS uses two or more CPUs to perform multiple tasks at the same time, increasing speed and efficiency. Your phone as well is an example, also a multiprocessing OS. Okay, because there are some Android operating system who uses, I'm coming, I want to check my phone, that uses called processor and the likes. So it's an example. It just means more than one CPU performing different tasks at the same time. Okay, more than one CPU performing different tasks at the same time. Performing different tasks at the same time. The core. You can, you know, check more on this if you don't understand, or if you don't understand, let me know if I should be explaining in another video. Now, multitasking. Multitasking allows a computer to run several programs or processes concurrently. Concurrently means at the same time. Appearing to run at the same time. Okay. So you can be playing music. I don't know if your phone can do that. You can be playing music on music app and be listening to audio on WhatsApp. Are you getting my point? And also be texting on WhatsApp at the same time. That is multitasking OS. It's not multiprocessing, it's multitasking. Now, if each task is now being done by different CPUs, that is multiprocessing. Okay, that is multiprocessing. Okay, sometimes it might not mean that you are listening to music, you are doing all of those things. It could be that a CPU, one CPU um is translating, another CPU is doing another thing in the background. Okay, maybe it's another CPU is downloading for you, then another CPU is one, you know texting, the text that you are doing on WhatsApp. So that is, but if it is many CPUs doing the processing, the tasking at the same time, that is multiprocessing. But if it is just doing different tasks at the same time, that is multitasking. So your phone is single user, multiprocessing, and multitasking. Okay, your phone is single user OS, multiprocessing OS, and multitasking OS. Now, the fifth one is networking OS. What does networking OS means? It means manages and controls resources on a network and allow users to share files, printers, and other resources. Okay, files, printers, and other resources. Windows Server, Unix, Linux, Cisco, iOS, Novel, Netware, and so many more networking operating systems. So, what is now the difference between, I think I've explained the difference between networking and multi-user. Okay, I think I've explained the difference between networking and multi-user. So, another attribute of networking is that you can share resources, okay, on the network and allow users to share files, printers, and other resources with themselves. Okay, so this is mostly, you have networking, even your Jam CBT, networking OS, multi-user OS. Okay, still an example of networking OS, multi-user OS. So window-based OS, this one is just talking about any computer that uses Microsoft. Okay, so developed by Microsoft, it manages resources and provides a graphical user interface using windows, icons, menus and pointer. Examples, you have Windows 11, Windows 10, Windows 8, Windows 7, Windows Vista, XP, and many more. GUI stands for what? Graphical user interface. Okay, so mobile OS, this is your Android, your iPhone, and others. Okay, so designed for mobile devices like smartphones, tablets, wearables, manages hardware and software, connectivity, and apps. Okay, and lastly, you have the cloud OS. Okay, and this one manages and delivers cloud-based services and resources, coordinate storage, computing, power, and networking. So, like AWS, Amazon Web Services, is an example of operating system, cloud operating system. In part two, part three, chapter two of IT, we explained cloud storage. So, cloud storage, all the devices uses cloud operating system. So, what is a quick summary here? OS can be classified based on numbers of users, numbers of processors, stacks, handled, network capability, platforms like desktop, mobile, cloud, and interface types. So all these types of OS aim to manage resources and provide a better user interface. That is what is designed to do. So which OS do you use on your phone, on your laptop? Why are they different? So examples you should know: Windows, as you can see, Windows single user multitasking, Linux single user multi-user, multi-processing, networking. You have Android, mobile operating system, and so many more. So that is for slide 4. Now let's move on to page 5, which is Bootstrap program. This one is not mentioned in the 5 major types of system software, but it is still part of system software. Okay, Bootstrap program. What does it mean? I told you that we have in our main memory, I said we have RAM and we have ROM in chapter 2, part 3. And I told you that ROM is, in terms of capacity, is very small. And the reason why it is small is because what it does is it loads, okay, it loads the operating system. Before operating system, that is the memory that is at work, okay, to load operating, because operating system is not in RAM or ROM. And when the system is on, you need RAM to be working. And because we know that RAM is volatile, that is, when you switch it off, everything in it is off. So it is comes to zero. And I even give examples. And I said there are some phones, I don't know if you use that kind of phone. When you minimize, okay, you will see the number of RAM, you see the total number of RAM and the one that you have consumed so far. And when you cancel all the applications that you've opened, you will see that the number will reduce. Okay, when you switch off your phone completely, everything go back to zero. Do you understand what I'm trying to say now? Because there is nothing. RAM is volatile, but you need RAM for the system, for the phone to work. Okay, so your operating system is not even stored in the RAM, it is stored in the secondary storage. So something needs to take the operating system to the RAM. Okay, and that is the work of ROM. That is the work of Bootstrap program. Okay, that is the work of Bootstrap program. So we can say that Bootstrap program is stored in ROM, because I told you ROM is the memory that checks input, output, do all of those things. Because when you switch on your computer, when you actually off it, not sleep it, when you switch on your computer, you will see it will load and, you know, do some things before going to the desktop, okay, where you see your icons and everything. So that is what Bootstrap program is all about. When you switch on your iPhone, you will see the iPhone icon. That one, Bootstrap loads the icon, the iPhone operating system, to the RAM of your phone before you will now see your home page and the applications that you have and every other thing. Then you now do what you want to do with the phone. Maybe make a call or do transfer or watch your academy video on YouTube or read your or go through past questions. You get what I'm trying to say now. So that is Bootstrap in a nutshell. But let's read what we have. Bootstrap program. What is it? Bootstrap program is the first program that runs when the computer is switched on. Okay, so when the computer is switched on, Bootstrap program is the first thing that runs when the computer is switched on. It is stored permanently in ROM. Bootstrap is stored permanently in ROM. Its main job is to load the operating system into RAM so that the computer becomes ready for use. Because we said operating system is like the manager between the user and the hardware. So something needs to take the operating system to the RAM because RAM is volatile, just like I explained. So the boot process now, what is the boot process? When you switch on, the user switch on the computer. This is number one. Number two, Bootstrap program, which is found in the ROM, the Bootstrap program in ROM starts executing. Okay, it moves to the third one, which is loading operating system. It locates the operating system on storage like hard disk or SSD and loads it into the RAM. Okay, and the fourth one, operating system start. The operating system is now in memory and takes control of the computer. And lastly, the system is ready. The user can now use the system just like I explained. So what are the key factors? Because I don't want to waste much of our time. The key fact is that Bootstrap is stored in read-only memory. That's ROM. Runs automatically when power is on. Loads the operating system into the RAM. Hands over control to the operating system once it has loaded to the RAM. Without it, the computer cannot start. Okay. It is the starter of the computer. It loads the operating system when the control is when which then controls everything. It ensures the hardware is checked. It ensures the hardware is checked and made ready. It makes the computer operational. It makes the computer what? Operational. Now, utility programs. What are utility programs? So, utility programs are system software designed to perform maintenance and support tasks that help keep the computer system running efficiently and smoothly. Utility programs are system software designed to perform maintenance and support tasks that help the computer system running efficiently and smoothly. So what are the importance of utility programs? It keeps the system reliable, it improves performance, protects data, saves time and reduce error, help maintain storage devices. Okay. Now, common utility programs and their functions. We have file copy. Yes, file copy is a utility program. When you want to copy a file from one location to another, it's being handled by utility programs. We have file reorganization. We have file maintenance, checks and repair files, remove errors and keep files healthy. Sorting is an example of utility programs. It's being done by utility program. Backup and dumping routines being done by utility programs. housekeeping operations. This means clean storage, remove temporary files, update file labels, and common data. That is housekeeping operation, and it is being done by utility what programs. Format conversion, convert data from one format to another, is being done by what utility program. This copying and formatting, copies entire disks or format disks to prepare them for use, is being done by utility programs. So that is for what utility programs. Now, what are the quick summary? Number one, Bootstrap program is the first program that starts the computer and loads the OS, that's operating system, into the memory. Utility programs are helper tools. They are what? Helper tools that maintain, protect, and improve the performance of the computer system. And that is for page 5. Now, let's move on to page 6. So here is where we want to talk about the loader and editors. Okay, the loader and editors, then language processor. So loader, I know somebody, after explaining this, someone might be confused, but I'm going to explain. Okay, what is a loader? What does a loader do? Okay, a loader is a system that places a program or program segment from secondary storage into main memory RAM, so that the program is ready for execution. So a loader is a system program that places a program or program segment from secondary memory, hard disk, SSD, etc., into main memory, so that the program is ready for execution. Okay. So what are the key points here? It runs after the Bootstrap program. It loads the program into the correct memory location. It prepares the program for execution by the CPU. The assembler compiler produces object code, okay, which is the input to the loader. Now, I'm going to explain, because if we say we have loader and we have Bootstrap, so what is now the difference between Bootstrap and loader? Thank you very much for that question. So the difference is that apart from operating system, there are so many other applications. There are so many, not applications, so many instructions that are stored in the secondary storage. Okay. But the first that needs to be out of the operating system or of the secondary storage is operating system. Okay. To load the computer to get to operating system is now being done by Bootstrap. Okay. It's being done by Bootstrap. So Bootstrap only loads operating system. Loading of other applications is being done by loader. So Bootstrap and loader, they have the same function. The only difference is that Bootstrap loads operating system and hand over the computer to the operating system once it is in the random access memory, which is the RAM. While loader takes other applications. So if you want to use WhatsApp now, it will now take WhatsApp from secondary data to the RAM for use. Do you understand it now? So that is the function of loader. How loader works? Let's say this is the secondary data, secondary storage, where WhatsApp is or TikTok. Okay. So loader now takes it to the main memory, and that makes the program ready for execution by the CPU. Okay, which is the central processing unit. And that's the difference between loader and Bootstrap. Now we have editors. Now, this is actually for programmers, all right? It's actually for programmers, okay? But you still have to know about them. So editors and system programs used to create, change, and prepare programs, source code, okay? Source code. Object code means, I forgot. Object code means machine language. Okay, it means what? Machine language. So editor means um the system programs that, I'm trying to check my pen. I'm trying to check my pen. Okay, okay. The machine language. So editors are system programs used to create, change, and prepare programs, source code or other files. Okay, source code or other files. This is machine. So now we have text editor and we have linkage editor. We have text editor, we have linkage editor. So text editor is used to create and edit a program, source code, okay, which is high level language, okay, or low level language. We are still coming to that. So is used to create and edit a program, okay, that's text editor. It does not check the syntax of the code. Example is Visual Studio Code, that's VS Code. You have Notepad, you have Edit Pad, and so many other um, text editor. Now we have linkage editor. Linkage editor. I know you must have heard of text editor, but not linkage editor before. So what is now the function of linkage editor? What does it mean? It's used to link together several object programs, okay, and resolve references between them during program compilation. All right. So example is linker and linkage editor. Now let me quickly explain linkage editor to you. If you go to the download file of your application, let's say WhatsApp for example, okay, for example. Now when you open WhatsApp, you will see so many things, so many files, like so many. It's not just one file, okay, so many of them. So linkage editor, the work of linkage editor is that when it is running the program or when it is installing the program, when it is running the program, okay, it's, link everything together so that they can function as one. For, graphic designers now, your Corel Draw now, when you open the app, the file, Corel Draw file, you see a lot of small edit like code edit, maybe notepad, you will see it in the notepad form, a lot of them. So linkage editor links everything together, makes it one, so that you don't need to be taking this one, take this one, take this one when everything is running, okay, or when you are using the application. So that is now the function of what? linkage editor links object programs together. Okay, while text editor creates and edits code. So language processor, I want you to pay attention here. So um, a language processor or language translator converts the user's code, which is the source code, written in a high level or low level language into machine code, which is the object code. Okay, which is the object code. Now, what is the difference between source code and object code? Source code is written by humans, okay, in a programming language. C, C++, Python, Basic, and so many of those source codes. Now, the object code is the machine code, which is the binary, which is understood by the computer. That's the object code. Okay. So what converts source code to the object code is language translator or language processor. Okay. Because the computer can only understand zeros and ones. So if you create to write a code, an application in zeros and ones will take you like forever. Are you getting my point? Like the kind of applications that we use this day, how complex they are. To write them in object code will take you like forever. So people write in high level language, more of high level language than even low level language. Okay. But even if you write in low level language, you still need a language processor to convert the language in which you have used your text, your editor, okay, text editor to write. That's to write the high level language or the low level language to convert it to what? The object code, which is the machine code. So, because the computer only understands binary, the computer only understands what? Binary, which is zeros and one. Therefore, the source code must pass through a language processor to convert it into machine code before it can be executed. Okay, before it can be executed. Now we have three main types of language processor. We have assembler, compiler, and interpreter. We have the assembler, compiler, and interpreter. So what does the assembler do? The assembler translates low-level language, which is assembly language, into machine code. So assembler translates low-level language, okay, to object code, which is the machine language. Okay. So the key point about assembler is that it works with low-level language and produces object code. So when you think of low-level language, and the translator that comes to you should be assembler. Okay. Now compiler. Compiler translates high-level language into machine code in one go. You should take note of this. One go. Okay. One go. It translates everything at the same time. So the graphical explanation is high level language, C++, C, JavaScript, and so many of them. Then we have compiler that compiles everything, okay, to object code, which is the machine code. Now, what are the key points here? It works with a high level language, translates the entire program at once, produces object code. Example is GCC, Tobos, C++, Java compiler, and okay, C++ is high level language. So C is an example of compiler. Okay. Now we have interpreter. Interpreter also translates high level language line by line while the programs is running. I'm going to explain the difference. Okay. So the graphical explanation is you have high level language, which is basic Python. Then you have interpreter. Then you have your object code. Okay. But the thing is, there is no object code produced in interpreter. Okay, there's no object code produced. It's not as if it doesn't create object code, but the object code is being executed as at that time before moving to the next code. Okay, I'm going to explain. Um, Compiler, your application software, in short, most of the software that you have on your phone is being done using compiler. Okay, and this one is even done before you download the application, before they get to Play Store or Google Store or any store that you use to download applications from. Okay, this has been done, okay, before all of that, because this is the language. This is high level language, program written in high level language. But because you want to use it on your phone and your phone does not understand high level language, so your application is then compiled everything at once to machine, what to machine, to object code before being sent to where, before being sent to, wherever you get it from, Play Store, your application disk and everything. So that is compiler. Everything is being compiled together. Let me give you like a real life example. Now, if you go to buy um like a biscuit now, every process must have been created, must have been done before you even buy it. It's not when you are buying that they do the creation, they grow the wheat, grind the wheat, mix everything that they want to, or the flour, mix everything together, then produce the biscuit and give it to you. No, they must have done everything, package it before it is something that you can eat. All you just have to do is open the nylon, pick what you want to eat and eat, right? Because that is what the computer understands. But there's the biscuit is not grown as biscuit. Okay, it is grown as flour or wheat, or depending on what they use. Okay, but it's now being mixed and everything is being done by the producer before it gets to you. Okay, so likewise, it is the code writer that uses compiler, okay, before it gets to you. All right, that is for compiler. Now interpreter. Now interpreter is more or less like an application that is not an application. I'm going to explain. Interpreter uses interpreter takes the code, okay, one at a time when running, okay, while the program is running. It translates high level language line by line while the program is what is running. Now this can be done before it gets to you or when it gets to you, depending on the software and the instruction that you are using. Okay, but I don't think that they will even ask you all of this kind of question. I'm just explaining for you to have a better understanding of the difference between compiler and interpreter. So now imagine interpreter now is um you eating the biscuit. Okay, you have to first open the biscuit, pick one, eat it before you pick another one. Okay, now you are going to eat everything, oh, but you pick one after the other because you cannot force everything into your mouth at the same time. All right, so you pick one, eat, pick another one, eat, pick another one, eat till the biscuit is what is it is finished. So that is how interpreter works. Okay, it translates and executes one statement at a time. No object code is produced. Slower than compiler. You have Python interpreter. Most of the time, Python codes are like interpreter. They use interpreter a lot. Python, especially Python. when you are doing what's it called? There's something called, it's not simulation, like when something is being done for you. I'm like, what is this thing called? I've forgotten right now. But you know, when you create bots, yes, it's bots. I'm trying to remember bots. So when, especially those that are into trading, you have a trading bot. The trading bot executes program for you. Now they read the program one after the other. That's how they work. And that's why most of the bots are being created using Python. Okay. So they read the bots one line after one line at a time and execute that line at a time, because they need to do that because it is step by step. Imagine that they read everything, they now copy it, and there is error. They have to first log in. After they log in, they have to look for the kind of signal that you've imputed. They have to now go to the database and check how much you said okay they should trade with, check all of those things before they now execute. But all of those are being read line by line and executed line by line. You get what I'm trying to say now? So that is how interpreter works, and that's the difference between compiler and interpreter. One similarity between the two is that they translate high level language into machine code. They translate high level language. Okay, one generates machine code, the other doesn't generate machine code. Okay, no object code produced, because it executes, it interprets and executes immediately. It's not as if object code is not produced, but it's not the entire object code is now being produced before being interpreted, be executed. Do you understand? So that is for language translator. I hope you understand. I just hope you understand. So um example, we have assembler, compiler, and interpreter, and you know what they stands for, what they do, and how they works. So um assembler is object code, compiler object code, interpreter no object code. Assembler is fast, compiler is faster, interpreter is slow. But assembler is low level language, compiler is high level language. Okay, interpreter is also high level language. And that is for slide for page 6. Now let's move to page 7. Advantages and disadvantages of interpreter over compiler. This video might be kind of long. It might be kind of long, but it's gonna worth it. I believe it's going to worth it. Or maybe I should just end it at, but everything fused in together. That's just the truth. Everything fused in together. So advantages and disadvantages of interpreter over compiler. Advantages and disadvantages of interpreter over compiler. Both interpreters and compilers are language processors that convert high-level language. They convert high-level language programs into machine language. Okay. However, they work in different ways and have different strengths and weaknesses. Advantages of interpreters over compiler. Now, interpreter, easy debugging, just like I told you, because it is translating and executing line by line. There is easy error detection and easy fix. So that's called debugging. So there is easy debugging. Errors are detected and reported immediately at the line where they occur. There's immediate execution. The program starts running as soon as it is typed. No need to translate the entire program first. No object code file. No separate object code is produced. This saves strong storage space on disk. There is low memory requirement because it's not producing object code. Okay, there's no memory requirement. Low memory requirement. Interpreter need less memory because they translate and execute line by line. There is easy program modification. Changes can be made and tested immediately without recompiling the entire program. Okay, good for small programs and testing. Best suited for small programs learning, prototyping, and testing new ideas. Now, disadvantages of interpreter over compiler. One is slower execution, repeated translation, because every time it has to translate, every single time. Imagine the bot has done its work today. You want to do the same thing next tomorrow. It has to, you know, repeat translation all over again. Okay, it will repeat translation, execute, and every time you are using that bot, it has to do that repetition every single time. So that is one of the disadvantages of interpreter. Repeated translation, the same lines are translated every time the program runs, causing time wastage. It is not suitable for large programs, inefficient for big or complex programs due to slow speed, more time consumption, no permanent object code. No object code is stored for future use or faster execution. Okay. Then you have less efficient. It is what? It is less efficient. That's for that. It is less efficient. It is less efficient. So want to move to interpreter versus compiler. The comparison at a glance. Interpreter versus compiler, the comparison at a glance. Okay, the comparison at a glance. Now, features. Now we have the first one, translator. We have speed. We have object code, memory usage, error handling, execution, best use, example, languages. So for interpreter, you have translate line by line and execute immediately. That's for translation. While compiler translate the entire programs at once before execution. Okay. Speed. Interpreter is slower, while compiler is faster. Object code. No object code is generated for interpreter. Object code is generated and stored for compiler. Memory usage. Low memory usage by interpreter. High memory usage requirement by compiler. Error handling. Errors are reported one at a time. All errors are reported after compilation. It is after compilation for compiler that errors are what are reported. Program starts running immediately. That's for the execution of the interpreter. While programs run only after successful compilation. That's for compiler. Best use small programs, testing and learning. While for compiler you have large programs, production, efficiency needed. Um, example of languages, you have basic, Python, JavaScript, PHP. Yes. While for compiler you have C, C++, Java, Pascal, Fortran, COBOL, and the likes. So those are the comparison at a glance. What are the key takeaways? Interpreters translate and execute line by line. That's what you should remember. That's number one. Compiler translate the entire program at once. Interpreters are easier for debugging and testing but are slower. Compiler are faster and better for large programs but requires more memory and time to compile. You have to choose the right tool for the right job. So that is for the page 7. Now we are moving to page 8. After this page, we only have 6 more pages to go. We only have 6 more pages to go. Now, associated phenomena. Associated phenomena. Don't know why this pen is in this. Okay. Associated phenomena with software, with system software. So associated phenomena are special features and environment provided by system software that improve the way computer and users interact and perform tasks. All of these are the things that we have discussed before. Okay, multi-user application, multitasking environment, multi-programming environment, multi-processing environment, spooling and virtual memory capability. I think you remember multi-user application allow a number of users from different departments or locations to use the computer system at the same time, time sharing to process their own jobs on an online basis. So this is an example of a multi-user application. Um, we have multitasking environment, the ability of the operating system to uh, execute a user's task concurrently at the same time. Printing a document while the user is typing another document simultaneously is like an example of multitasking environment, which I believe we have explained. Multi-programming, okay, multi-programming environment. Now, multi-programming is different from multi-processing, okay. Multi-programming is a situation where several programs are kept in the main memory at the same time and the CPU works on one program while switching to another. Okay, several programs are kept in the main memory at the same time and the CPU works on one program while switching to another. Okay, there's program 1, there's program 2, there's program 3, there's program 4. CPU switching from one program to another when one waits for an input or output operation to complete. That is multi-programming. Only one program executes at a time. Other programs remain in memory. Improve CPU utilization. Okay, that is multi-programming environment. Time sharing gives each user a fixed time slice, while in multi-programming, CPU switches based on input or output wait. Multiprocessing involves the use of several CPUs linked together to perform coordinated work at the same time. Okay, so that's the difference between multi-programming and multiprocessing. Multi-programming is one CPU, different programs stored in the RAM, while multiprocessing is different programs, different CPUs working together, okay, at the same time. Now, what is spooling? Because we have not talked about spooling and virtual memory capability. So spooling, which the word spool stands for simultaneous peripheral operations online. SPOOL. Simultaneous peripheral operation online. That's spool. So spooling means is a method of improving the efficiency of input-output devices by queuing jobs for a slow device so that the CPU does not have to wait. Okay, is queuing. That's just what spooling is all about. Queue. Now, I don't know if you have used some printer that when you send documents to them, they don't print all the documents at once, they print it one after the other. Even if the system is off, no, the system have to be on. But even if you've left that place or you are doing something else, or even if the printer switch off and they bring back the light and you switch on the printer, it will still print those documents out before it print another one, unless you go to cancel it. I don't know if this thing has occurred to you before. So spooling is like when there's so many work sent to a printer. Let me use a printer now for an example. Spooling is like the place where everything is stored and being sent to the printer one after the other. Okay, so how spooling works: there's user, there's input device, there's spool file on disk, then output devices. So the benefit of spooling is to improve CPU utilization, allow slow I/O device to work in the background. Jobs are processed in order they arrive. That's FIFO, first in out, first in, first out. Okay, FIFO. So just like I told you, they will first print those ones before they print another one that you now send. Unless you go to cancel them, you cancel that job if you don't need the file that you want to print, if you don't need it again, that's when it will now print the next one. Do you understand my point? That is spooling, which the word spool stands for simultaneous peripheral operations online. Now we have what we call virtual memory capability. What is virtual memory capability? Virtual memory capability is referring to um, when the OS uses secondary storage as an extension of the RAM, giving the illusion of a very large memory. How does it work? Main memory, you have RAM. Then you now have virtual memory, which is taken from secondary storage. Okay. Now, let me give you an example. Let's say you have a table that can only contain 5 books. You have a table that can only contains 5 books. Okay. But you have about 20 books that you need to read. So you have a shelf where you stored the remaining 15 books. That shelf is not the table. But if you are like being asked, how many books are you working on? You say, I'm working on 20 books. But the table can only take 5. But there is a shelf in which you stack the remaining 15. The shelf could take more than 15, oh, but because you need to work on 20 and your table can only take 5, you now store the remaining 15 on the shelf. So if you are done with one or you need one, you take one from the table and bring another one from the remaining 15, to still make sure you have 5 and 15. So that is how virtual memory works. Do you understand it now? So it allows programs larger than RAM to run. Mobile makes better use of available memory, improves system performance and capability. So that is how virtual memory works. And these are the what phenomena, okay, that are associated with operating system. Do you understand? Or system software. Okay. So that is how all of this works. And I think that is the end of system software. Now, quick summary. Associated phenomena are features of system software that help multi-users and multiple tasks run efficiently. They include multi-user, multitasking, multi-programming, multi-processing, spooling, and virtual memory. And I think we've done justice to those information. Now, the next one is application software. So we are done with system software. We now have application software. I should have made this second part, but we only have from 9 to 14. That's 9, 10, 11, 12, 13, 14, which is just 6 slides. And out of that 6 slides, we have about 3 that is talking um about softwares, application softwares that we are familiar with. So that's why I think it should still fall in part 1. Okay. So application software. Application software consists of programs, okay, designed and written to perform specific tasks for the user. It supports users in solving real life problems in different fields. So what is application software? Application software refers to programs that perform specific functions and support users in their daily activities. So think of what you use every day: TikTok, WhatsApp, Instagram, your Facebook, your your Facebook, your mobile apps, your bank apps, your gaming apps, your reading apps like WPS, like Adobe Acrobat, and many more are all application softwares. Okay. One thing that you should remember, keywords that you should remember is that they are specific, they perform specific functions. Okay. Application software refers to programs that perform specific functions and support users in their daily activities. Now, categories of application software. There is user application programs, which we call um, in-house packages. Okay, we call them in-house packages. Then we have application packages, which we call off the shelf packages, which are pre-written programs designed for general use by many users. Okay, so that is example of the categories of application software. Now, features of application software: it solves specific user problems, easy to use and user friendly, works on top of the system software, helps improve productivity and efficiency, can be customized to meet user needs. Example: MS Word, Excel, database, AutoCAD, your Sage, your QuickBooks, your Zoho, your your accounting packages. All of the likes are examples of application software. Now, importance of application software: it solves real life problems, improves productivity and efficiency, saves time and reduce manual work, helps in better decision making, support business operations, increase profit and performance. Now, user application programs. User application programs. I told you that we have two categories of application software. We have user application programs and we have application packages, which are off the shelf packages. So, what are user application programs? These are application programs developed by an organization to solve that organization's specific problems and meet its unique requirements. It is designed by an organization. They might not be the one to design it by themselves. They might pay a developer to develop it for them, but it is developed for that organization to solve a specific problem and meet its unique requirement. That is, it is for that organization. Okay, it is for that organization. That is user application programs. Examples of user application programs are decision support system, DSS, expert systems, artificial intelligence. So DSS helps managers make better decisions using data, models, and analysis. Sales analysis system, inventory control system, financial forecasting system. All of these are decision support systems. Okay, expert systems uses knowledge and rules of expert to solve problems normally done by humans. Medical diagnosis system, engineering troubleshooting, credit approval system. All of these are expert systems, user application programs. Artificial intelligence enables computer to perform tasks that normally require human intelligence. Chatbots and virtual assistants, facial recognition systems, language translation systems. All of these are, user application programs. Now, we have application packages. So these are pre-written software. It's not as if you are the one that asks the software producer to produce it for you. So these are pre-written software package developed for general use. Okay, they are ready made and can be purchased off the shelf for use by many different users. Types of application packages: you have spreadsheet packages, you have word processing packages, database management packages, graphics generator, desktop publishing, statistical packages, mathematical packages, and all of the likes are what we now look at one after the other. Example of application package: you have Microsoft Excel, Microsoft Word, Microsoft Access, Corel Draw, Adobe PageMaker, SPSS. Other areas: MATLAB, AutoCAD, Tally. This Tally is being used, sometimes used um, um, for Tally is used by accounting. It's used for accounting. I think it's accounting software application package. You have database. You have Photoshop for photographers. You have Control Pro. I don't know who uses this one. So that is application packages. All right. So I believe you should be able to differentiate between in-house and off-the-shelf application packages. All right. So Exam tips. You might be asked to define application package, differentiate between user application, programs, and application packages. Give examples of application packages, state the importance of application packages. Any question can come from this angle. Now, quick summary. Application software solves specific tasks. That's number one. Okay, they solve specific tasks. It has two types, which is the it has two types: user programs pack and packages. User programs are custom made. That's the right word for an organization, while packages are general purpose and ready made. Both may both make they both make work easier, faster, and more effective. So that is the what quick summary. Now we are moving to page 10. So we want to look at spreadsheet and word processing packages. So I know you should have seen spreadsheet before. Some people will say Excel, but Excel is the name of the package. Okay, spreadsheet is what it does. Okay, so application packages are pre-written software program designed for general use by many users. This page covers two important application packages, which is the spreadsheet and word processing packages. Like your Microsoft Word now is a word processing package. Okay, your Microsoft Excel is spreadsheet package. I use both Microsoft Excel and OpenOffice Calc. I use both Microsoft Excel and OpenOffice Calc. Many of them have the same interface because they do the same thing. They do their spreadsheet packages, but you know, there is a topic, like a subsection, that will explain more about why we have different organizations having their own application packages. Okay, so spreadsheet packages are programs used to organize, analyze, and present data in rows and columns. Okay, which is known as the worksheets. What can they do? What can spreadsheets do? Can perform calculations, create tables and lists, use formulas and functions, sort and filter data, create charts and graphs, analyze and summarize data, print report and worksheets, save data for future use. I think there was a time I was I had a class um on spreadsheet package, how to use, because it is very, very important for you. It is like very, 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 very important for you as an upcoming accountant to know how to use Excel. At least know the basics of Excel. Very, very important. So if you want to, you can reach out, and if you can get it elsewhere, very, 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 you are very, very welcome. So, but it's important that you do what um that you know how to work on spreadsheet packages. Microsoft Excel, Open Office Calc, anyone, Lotus 123. Okay, Quattro Pro is also spreadsheet package. I'm just saying this now. So all of these are being done by spreadsheet packages. Okay, that's what they can do, and the examples are listed here. Component of a worksheet: you have your column and you have your row. This is just a tip. Okay, you still have a lot to learn, but this is just a tip. So you have row, you have column. You see these numbers here: 1, 2, 3, 4, 5, 6, 7, and the likes. Then you have your column: A, B, C, D, E. So then you have what we call cell, which is where a row and a column intersect. So this, like this, is a cell. Okay, so when you hear B2 now, B2, column B under row 2 is cell B2. Okay, so that is how it works. Horizontal arrangement of cells, vertical arrangement of cells. Okay, that is column and that is row. So advantages of spreadsheet package: easy to use and learn. They are easy to use and learn. solve times, saves times and reduce manual work, helps in accurate calculations, errors. That's the disadvantages of spreadsheet now. Errors in formulas can lead to wrong results. So large data may slow down the program. Worksheet can be deleted or altered easily. That's the disadvantages. Now, word processing packages. I believe you know much about this already. Word processing packages are programs used to create, edit, format, and store and print text documents. What they what they can do is listed here: create new documents, edit and revisit revise text, format text and paragraph, insert table, pictures and charts. All that you can do: check spelling and grammar, find and replace words, save and print documents, mail, merge and templates. All of these are what you can do on word processing package. Example: Microsoft Word, Word Perfect, LibreOffice Writer, Google Docs, Open Office Writer, WordStar, Word Perfect, Microsoft Word. But Microsoft Word is the most common, okay, because a lot of computer uses window, okay, uses window, okay, uses window. It's not as if because they use window, that's why the Microsoft Word is on them. Even I use window and I have LibreOffice, okay, so that's not the only reason, but I'm still going to explain how it's, because there's a part, just like I told you, that talks about the reasons why we have all of these dynamics. So features of a word processor. I think you know virtually everything on word processing packages. I don't need to explain more because these are just basic of what is being done in Microsoft Word or WPS Word, anyone that you use. So if you want to read through everything, you can pause the video and just read through or jot down if you want to do that, because I don't have much time left. So um we are moving to the um next page, which is page 11, and that is database management, graphics generator and desktop publishing. Okay, so DBMS, which stands for database management system, um are used to store DBMS are used to store, organize, manage and retrieve large amounts of data efficiently. Okay, what can DBMS do? DBMS can store data in an organized way, allow easy access and retrieval, update, insert and delete data, generate reports quickly, reduce data redundancy, maintain data integrity and security, support multiple users at a time. Example of DBMS package: you have DBase, Microsoft Access, Oracle Database, MySQL. This is the most used um, database database management packages. Okay, most used um, by that is programmers. So you have PostgreSQL, Apache, Cassandra. I don't even know this. So that is for DBMS. I'm going to explain DBMS, okay? Because some people might be thinking that DBMS is the same thing as file manager on your phone. No, they are two different things, okay? DBMS is more than arrange your file, okay? It's beyond organizing your file. That's what file manager um, allows you to do. Also, it's beyond access and retrieval, beyond modification of file, okay? It's beyond that. Your file manager cannot generate reports, cannot reduce data redundancy. You just store your data and it's in your file manager and it just shows there. But your database management, in short, database management is more complex than file manager, in the sense that database management is used to store everything. Okay, now you have there is no application without database management. Even your WhatsApp has database management. Okay, because that is where everything is stored. All right, just like the way um you need storage. You need storage to save things. You need database management for application to function. Okay, for application to function effectively, because even the code of the application is saved in a database management. That's one. Two, the information of the users is saved in database management. That's why the code can remember your username and password, because everything is stored in database management system. Do you understand? Also, your database management system has um, information that is necessary for your transactions to happen. The 50,000 naira that you are seeing on your account balance is because it is stored in database management. So when you withdraw money and you see a change, something needs to be affected so that it can correspond. It will always show that it will always tell the computer that you have so amount left. So everything is being done in database management packages, database management system, and that cannot be done in file manager. You understand? You see why they are different. So file manager is not um, database management system. It is just an integral part of database management system. Do you understand it now? So that is for database management system. So a database is a collection of related data files that are integrated and organized to provide a single comprehensive system. Okay, so a DBMS, database management system, is software that builds, manage, and provide access to a database. Now we have generator, graphics generator, and desktop publishing. So graphics generator are programs used to create and manipulate visual graphics and charts. Okay, so what can they do? They can create charts and diagrams, draw lines, bars, pie and scatter charts, design flowchart and illustration, edit and enhance graphics, import and export images, use in presentation and report. So examples is Microsoft Excel charts, CorelDRAW charts, Adobe Illustrator charts, Google charts, Matplotlib. All of these are examples of graphics generator. Types of graphics. You have line chart, bar chart, pie chart, histogram, scatter plot, scatter diagram. I think this scatter diagram you will still do it in your. I think you should have come across it in chapter one of your quantitative analysis. Then you have your flow chart. All of these are examples of charts. Okay, types of graphics being generated in graphic generator. Okay, so we have desktop publishing. Desktop publishing DTP software is used to create professional looking documents for print and digital publishing. So what can DTP do? Combine text and images and graphics together, control layout and page design, use different font and style, create magazines, brochures, flyers, etc. Prepare document for printing, and so many more. Desktop publishing. There are so many applications now that are you know that are being used for graphics designing, but all graphic designing is desktop publishing. They use what we call desktop publishing. Okay, they are used for desktop publishing. PageMaker, CorelDRAW, Microsoft Publisher, Scribbles, Quark Express. All of these are examples of desktop publishing. and is used for books and ebooks, majorly used for books and ebooks design, magazines and journals, brochures and flyers, newsletters, business cards and posters. They are used for that. So that is for desktop publishing and the like. So we move on to page 12. So we have two more pages to go. Now, statistical packages. Statistical packages are used to analyze data and aid decision making in management. Example: SPSS, SAS, Mini Tab, eViews, Stat Graphics, R. Yes, R. I know of this R and SPSS. Okay. Um, what can they do? Collect and organize data, perform statistical analysis, generate report and summaries, create tables, charts and graphs, helps in research and decision making, handles large sales of data efficiently. Use of statistical packages: business forecasting, market research, quality control, financial analysis, policy and planning, academic research. All of these are what we use statistical packages for. Now we have mathematical packages. That's the MATLAB, the Mathematica, Mapo, MathCAD, Skillab, and you know the likes. So application, they are used in engineering design, science research, physical modeling, financial modeling, weather prediction, simulations and testing. So mathematical packages are used to solve mathematical problems, equations and models. It's as simple as that. They solve linear equations, differential equations, numerical analysis, model real life problems, create simulations and graphs used in engineering, science and research. Okay, so we have what we call integrated software. This is where what I was talking about the other time comes in effect. Integrated software is a suite of programs that work together to perform a variety of related processing operations using the same data. Integrated software is a suite of programs that work together to perform a variety of related processing operations using the same data. So we have Microsoft Office, okay, Office suite, Adobe graphical something where you have your Photoshop, you have Premiere Pro, you have artificial, not artificial, After Effects. That's After Effects, AE. You have all of those packages together in one. So Microsoft Office as well. That's where you have Microsoft Word, Microsoft Access, Microsoft Excel, Microsoft Spreadsheet. You have all those applications together. Everything, that one application is called integrated software. Okay, it combines different. It's a suite of programs that works together to perform a variety of related processing operations using the same data. And that is why you can take the same data, or you can take it to After Effects and work on it. Take that same After Effects to Premiere Pro to have all of those, because they work together. They are called integrated software. That's why many applications have their own different version of packages, because they want to have their own integrated software. That's where those things come from. So what does it do? Combines different functions into one system, allows data to flow between applications, improve efficiency and productivity, reduce duplication of work, provides a seamless user experience, because you can take your video from After Effects to Premiere Pro, edit an image in Photoshop, bring it to do so many things, because it is integrated software. So how integrated software works: there's input data, process data, output report, then store image. Okay, so that is integrated software. Now let's move on to page 13. Page 13 is now talking about off-the-shelf packages. We know what it means, okay? We know what off-the-shelf packages means. So they are the applications that is being designed for, that is pre-written, okay? Those applications that are pre-written for everybody to use. Your TikTok, your WhatsApp, your Gmail, your Facebook, all of the likes are examples of off-the-shelf packages, okay? So what is the advantage of off-the-shelf packages? Written by software specialists, okay? It is written by software specialists, and so it has a very high quality. It is continuously updated. It is continually updated by software manufacturers, so the purchase version is up to date, tested and reliable. It is long in the market, so it will be error-free and well suited to the general public. Okay, you see, general public. Well documented. It will be well documented with ease to follow users' manual. Cost effective. It is cheap compared to in-house packages, which will take long time to develop and are costly. It is well tested. It is well tested so that the end user can start to use it immediately after purchase. It can be tailored as well, okay? In some cases, off-the-shelf packages are general purpose package which could be tailored to the user's requirements, unlike in-house package which are tailor-made, customized packages, okay? Like LMS, we have something called LMS, which is Learning Management System, developed by, is a general, is an off-the-shelf package, but it is still tailored, it's still custom based, okay? It's still tailored to people who want to teach online, like your Udemy, your Coursera, your all of the likes are they uses LMS packages, okay? And even if you want to have something like that, you can from these plugins you can download LMS plugins which you buy. So it is still off the shelf, but it's still tailored to the kind of purpose that those people want it for. But in-house is also tailored, but it is customized package. There are some things that you cannot change in the ones you buy, okay? But when you ask them to build it for you and you give them the specifications of what you need, it becomes what, um tailored made, that is not off the shelf package. Now, disadvantages of off-the-shelf package: standardized solution. Just like what I told you, there are some things that you cannot change. You produce standardized solution which may not be well suited to individual user. Now there's dependence on manufacturer. Okay, dependence on manufacturer. The end user will be dependent on the manufacturer or vendor in case of any serious troubleshooting or maintenance. The reason why I told you that Facebook is an example of off-the-shelf packages. Remember, Facebook had an issue about 4 5 years ago for, like, I think hours. It was not working. Nobody could log in. That they came out to see the number of billions that they lost for that few. I think that was what brought about so many social media um applications now coming up. Thinking, if this guy is making this such money, there's something going on in this market. So it is dependent on the manufacturer. Imagine that ChatGPT, you know they had issues. You are you are you are at their mercy. So even if they increase the fee, you are still at their mercy so far you want to use that application. So disadvantage of off-the-shelf package: dependence on the manufacturer. Number three, may lack special features. It's still talking about standardized solution. Compat Compatibility issues. Sometimes the off-the-shelf package may not be compatible with the hardware or data structure of the organization. So, like, now there are some applications that cannot work on some systems. It's not as if those application doesn't exist or the user does not want the application, but because of the hardware components of the system, okay. So there are some package that will tell you it has to be 64 bits, a system with 64 bits that they can run with, or a system with 80 something or 90 something, okay, or a system with so RAM, not 8 gig RAM. That's the system that you can install it on. So that is high memory requirement. high memory requirement, which is a disadvantage of the off-the-shelf packages. The off-the-shelf may demand for higher memory capacity, which may be very expensive for an organization. So those are the disadvantages. Now, comparison table is still what we have discussed about, that is still in the comparison table, advantage and disadvantage. So you can pause and read if you need to. So that is for that. Now to the last um page, which is page 14 for part 1. Whew, it has been a long way. So criteria for selecting application package. What are the criteria for selecting application package? Number one, feasibility report. That is, you have to indicate the choice between off-the-shelf and in-house package. You have to, do your research. Which one is better? Should we just hire a developer to develop the application for us, or we should just buy it and be paying some fee? Um, okay. So then purchase price is also another criteria that you should consider. RAM capacity, that's the memory capacity. Maintenance agreement, types of hardware and operating system required. Um, we have integration with other standard packages. Can the package be integrated with other standard packages? Will the new package accept download data, or do we have to now upgrade every other data now because we want to install this application, or because we want this application? So those are the criteria that every user must pay attention to before uh, selecting application packages. Now, history of usage elsewhere also matters. What are the story? That's why when you go on Play Store or App Store, no matter the store that you are using, there's something you see 4.5 rating over 5. That is, which is history of usage elsewhere, and you see comment of people, how their experience is, which is important for you to consider before installing or downloading an application package. Technology version also matters. Is the technology version of the package, uh, whether the package is the most recent model or the old ones or stuff like that. So those are the criteria for selecting application packages. Now, sources of application packages. Sources, that is acquiring them, getting application package. There is number one, mail order source, which is when they are being advertised in computer magazines and dailies. Most of the time you have this outside the country. Over the counter from retail shops or stores. If you go to Ikeja, if you are in Lagos and you go to the authorized counters, you can get the CDs. Okay, you can get the CDs, or they install it on your system, or they come and install it for you. So we have dealers in microcomputers. These are the ones you find in Ikeja and the likes. We have dealers, um, manufacturers of microcomputers, because there is no manufacturer of computer who is not a developer. So they can also develop software application package for you. Specialist organizations, software houses, they develop software for sale. Private organizations and institutions, okay, who have developed software for their own use, which they make available to other users for a fee. Okay, computer bureau and information center, in-house programmers, that is people who are employed to be a programmer in an organization, that is specialist staff of an organization who develop software as part of their official job routine. So that is all about the part 1. Okay, that is all about the part 1. In this part 1, we have learned about software, what software means, what the two types of the two categories: system software, application software. And we have dealt with system software. We have also looked into application software. So we are done with that. Okay, the next part is going to start with programming. Okay, We are going to start with programming, and that's what we'll be discussing in the next part. So thank you if you have watched to this point. This is a lot, and I appreciate you, and I wish you success in your examination. Please don't just watch. Have a notebook. Be serious with this thing. It's very important because it takes me time to create this, and it will be joyous for me to see you pass your examination based on watching this video. And I will see you, I believe, after watching this video and after writing your examination. You should be writing ATS3 soon. Okay, the next diet. So thank you. As always, please subscribe, share if you have not done so till now. It boosts my own morale to do more. So thank you. See you in part 2. Bye.